Well, we're nearing the end of the class, and I saved one of the topics that I think is the most interesting, and I have to tell you it's one of the most interesting to me. It's the one I do research in, and it relates to the data asset that organizations are being able to start to leverage with artificial intelligence, which is a topic we've discussed throughout this course. So I want to talk a little bit about the data asset and how AI fits in, and give you some context now for how things fit together and where we're headed in IT for sustainable competitive advantage. So to give you a little background, data is kind of a unique business asset. You know, an asset's something you normally buy and then it depreciates, but data, it turns out, its value grows with size and cleanliness, so that's a strange term, but clean data means that it's accurate, it's got information in it that's not missing, and it's not hard to read, it's digestible by computers. So good, clean data, its value grows with size, and over time, its cost per unit's actually decreased. So these data sets or assets that companies have are really the training sets for modern artificial intelligence algorithms, particularly those associated with machine learning. And I think I mentioned before that some of the BAT companies have been limited somewhat because of the inability to access a lot of repositories of English natural language speaking data. That will probably change as more data becomes available to them through their speaker systems and AI that they're building and launching into more European and US markets. So what is this data? Well, it's data about customers, suppliers, competitors. It might be data about the environment a company operates in. It might be data about their own employees and the job market. All kinds of relevant data can have a big impact on business decision making. And it will impact those five forces of Porter that we've been talking about, and it'll change the way that companies operate. So we typically talk about data as being structured or unstructured. Structured data is typically more transaction-oriented data where it's very regular. All of the data we collect maybe follows some standard format. Unstructured data is more like speech, natural language that people use. It could be text-based. A lot of the more recent vendor tools are being directed to do analytics on this unstructured data. The cloud really has helped drive down the cost of analysis. So what do I mean by the cloud? Well, Amazon Web Services we've mentioned before, and other ways that you can rent computing infrastructure and send your data there and do your analytics, and then once that's done, leverage those analytics inside your company. That's made it possible for organizations of smaller sizes to take advantage of analytics and their data assets. So using data, there's usually typically, I would say, three orientations. And you'll see this out there a lot. One is descriptive, where you provide statistics or other types of analysis to describe what the data is telling you. Another is predictive, where you're actually trying to leverage the data to predict future actions so you can take advantage of that prediction. And prescriptive analytics is where you actually say what you should do, or it's analytics that actually come up with a solution that say, here's the direction that you should move. Now, company cultures, to take advantage of data and analytics, they have to change to what's called evidence-based decision making. Now, we've been driving at that concept throughout this whole class. You've been studying how to debias your decision making using facts and analysis as provided through Excel. And part of that debiasing is to say, what actual evidence do we have when we do these calculations on the real data and see what the results are? So data is usually thought of as the raw material for information in descriptive analytics, and that relies, like I said, on statistics. You can use that data and report it to companies in dashboards. A dashboard is a way to see how things are progressing and leverages data to get everybody in sync in what they should do. For example, a dashboard at a airline's gate might show the number of people who are passing through that gate for the next flight and provide the attendants there some information on how to provide guidance to those people. Knowledge is usually thought of as kind of limited to what humans do because it's experience-based. And I think now the question that's happening out there is, can artificial intelligence start to match that humanistic experience-based knowledge? And we're producing machine learning algorithms that leverage or show knowledge in some sense, but not the same way that we humans encode it and express it. It's in a machine readable or a machine logic format. So thinking about data inside organizations, this is a big area of job possibilities and career growth. And structured data is typically put into big organized databases, and the unstructured data is often stored in what's called a data lake. Specialists that are called database administrators or stewards of the data in companies, and they're often supported by data governance boards or committees. And you need those committees because data is really leveraged by every functional area of the organization. So accounting may have a representative on the data governance committee, as well as marketing and finance, and of course the other functional areas of business. Now, data can be bought. It can be generated by the organization's transaction systems, and most companies have enterprise resource planning systems like SAP or Oracle. Those systems are a significant source for clean data that's used in analytics. Most often, though, your data needs some cleansing and it needs some coordination. And that's something called master data management that has to take place inside companies to keep that data clean and organized. So there's a lot that goes into managing this asset from the organizational side. Now, analysts or data miners, or some people call them data scientists, do data mining on data. And that's where they build predictive analytics, and those predictive analytics may come in the form of a model. So, for example, if we're trying to sell to a particular customer and our predictive analytics can produce an index that customer is more likely to buy, I might provide them with an offer to entice them into a particular buy based upon historical experience, knowing that offer caused a lot of other people to want to buy. So we're trying to discern patterns from historical data in data mining, and we can leverage that for predicting the future. Now, some of the limits to this data mining that companies do is their data may not be as clean, and also there's something called concept drift. And so this is when history, they call it history doesn't tend to repeat itself. And an example of this is when the environment changes very rapidly. Something is different than when that original data was created. So the predictive analytics that we might produce tend to drift and not be as relevant in for more. So companies have to keep an eye on problems with this concept drift. Now, your text covers some companies that are leveraging analytics to alter their supply chain management, customer relationship management, all of those things. These companies make major use of these analytics for competitive advantage. And of course, a big issue today is sharing data while you're still adhering to individuals' intentions for the use of their data. Even this morning when I picked up the newspaper, there was a story about Facebook sharing data with Amazon and Netflix, and the users didn't know that sharing was taking place, and it evidently has gone on for some time. So it'll be interesting to watch how Facebook reacts to that and confirms with its user base that it's maintaining its data in a private state.